are integrated to 41. Okay, so you have to have that the processes are integrated to 41. I didn't mention this, but it should be obvious. Okay, so I mean, let me just add this here. I will include a second version here soon, but I will add that basically that y and x are both integrated to 41. Okay, so they are non-stationary processes, and in a second step. Okay, so that's not going to be the step one. Okay, so this is not going to be, because here you have also a second version if you include a linear trend. Okay, so with a linear trend. Okay, so with a linear trend, basically you have the same thing. Okay, so you have a, and then plus, and then you have b times x, and then plus zt. Okay, so either you use the first regression, okay, so without trend or with trend, and if you want to include the linear trend, then I will include this as by means of the following parameters. So I will have delta t times t. Okay, so that will be the linear trend here, guys. Okay, as we have seen this in the different versions of the augmented Dickey-Fuller test, maybe remember this. Okay, all right. So, and either of the first or I mean, it will change, of course, the asymptotics. Okay, so if you include the linear trend in the regression, it will change the asymptotics more or less, but we're going to look at this. All right. So again, let me just summarize the idea. So what you do is you perform a regression, basically on the two processes, and you take the residuals and you test them with respect to stationarity. In the last chapter, we examined how to test for stationarity, right? You remember this, okay? So that was model 3, model 2, model 1, maybe remember that. I mean, it's a long time ago, but anyway. Okay, so, and that was part of the augmented Dickey-Fuller test. So using that, you can basically examine whether or not processes are stationary or not. And if you find that the noises are stationary, okay, then there is cointegration between the two. But here from this model, you don't know which process adjusts to the long run equilibrium. You understand? So it could be both, it could be just one, or it could be just the other one. It's not clear, and that's why it's called static model. All right? So you don't have the error correction model where this is examined. Okay? But this is a simple idea. All right? So, and that was also proposed by Engel and Granger in the original paper in 1987. So that was also part of that. So how would you detect cointegration? And that was just the first step towards that. Okay? Now here, again, so what you do is you perform an augmented Dickey-Fuller test on, okay, so you have the ADF test on the residuals. Okay? So that's what you do. Okay? So in that case, you can examine whether or not the residuals are stationary. So if the residuals are stationary, then basically you will have that there is cointegration between x and y. That's it. Okay? So maybe remember the augmented Dickey-Fuller test, or specifically the Dickey-Fuller test just without the lag differences. Okay, so it looks like this. We use model 3. Okay? And if you remember model 3, model 3 was the model without, the deterministic components. And the reason for that is, and I'm choosing model 3, is that because the mean, okay, the mean of the residuals is going to be 0 by definition. All right? So that was the easiest model. All right? So the mean of the residuals is 0, so that's why we choose model 3, which is without the deterministic components. Okay, so model 3, let me just add here, no deterministic components. So no linear trend, no constant constant, no intercept, nothing. Okay, so no deterministic components, and the reason for that has been that the mean of the residuals is 0 by construction. Okay, so if I don't know whether or not you remember the regression analysis, where basically you were looking at some properties of the residuals. Okay, so the mean of the explained parts of y is going to be equal to the mean of the total part of y, which implies basically that the mean of the residuals is going to be 0. So since the mean of the residuals is going to be 0, there is no need to assume whatsoever that let's say that the residuals are stationary at the around the non-zero mean or whatever. I mean, it doesn't make sense, all right? So that's why you choose model 3 for that. So model 3, okay, so no deterministic components, and the reason for that is because the residuals, okay, so these are the residuals, okay, have 0 mean, okay, by construction, okay, so that's the reason for that. Okay, how does basically the test look like? Maybe you remember this. Okay, so what we do now here is we take the differences of the residuals and regress them on the following equation. So here you have phi. Okay, so phi times yt minus 1, and then you include the lag residuals of z. Okay, so I'm not gonna emphasize them. Okay, so basically what we have is that, okay, so here you have the lagged residuals, okay, so these are the lagged residuals. I'm not using this pen, I'm sorry guys. Here you have some lagged residuals of the residuals. No, lagged, no, not the lagged residuals of, lagged differences, sorry, I was confusing here, lagged differences, again, so this is just as the second case, okay, and then, sorry guys, so I was confused here, and then you have plus some noise here, okay, let's call it epsilon t, okay, and this is the augmented version of the test because you take the lag residuals to eliminate autocorrelation for these errors here. Okay? Maybe remember that one. Because of course there is no consistency regarding the issue. I mean, there is no convergence. Okay, so the estimates are biased. Okay? Sorry guys, this is z here, not t minus 1. Z. Okay? All right, good. And maybe you remember this, okay? So, and in this case, right? So the Null hypothesis, and let me just recall this shortly. Okay, so the Null hypothesis states that phi is going to be equal to 0, and this implies that the process has a unit root. Okay, so basically that. This means that z has a unit root. Means that it is integrated of order 1. Because if that is equal to 0, then you have that the basically differences are equal to the noise, which means that the difference is stationary. So if the difference is stationary, then of course you have an integrated process. Okay? Because the long run variance of the noise is going to be finite. So that's going to be basically it. Okay? And if there's a unit root, basically, then there is no cointegration. So if you cannot project the Null hypothesis, all right, for the residuals of the previous model, then basically you don't have cointegration. Okay? This is what it means. All right? So basically here in this case, so y and x are not cointegrated. Okay? Because there is no stable long-run equilibrium between the two. Okay? That's what it means. And the alternative is that phi, okay, so the parameter phi is less than 0. Okay, so if the parameter phi is less than 0, then we have, of course, an autoregressive process, and an autoregressive process, blah, 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 blah. You know, that is stationary, blah, blah, blah. Okay, so we have this. So in this case, all right, so this states that Z is stationary, okay, with 0 mean. We already considered that. Okay, so that was part of the last lecture, basically. Okay, and of course, phi naught can be greater than 0 because in that case, the process would not be stationary at all. Okay, so then the process would explode literally. All right, in this case. So Z is stationary with 0 mean. So in this case, that this is equivalent to that saying that y and x are co-integrated. Okay, that's it. And the augmented Dickey-Fuller test is basically, I mean, has to be formed similarly in that case of the previous lecture. So if you can basically perform the augmented Dickey-Fuller test, you can also perform tests for cointegration. That's it. So it's not a big deal. I mean, this is an easy version, right? So I admit this is not the only version because there are more sophisticated, more complicated approaches, much more. But this is just an introduction to that, so just for you to understand the basic idea. Now, the only thing that changes here a little bit is the critical values. Okay, so the critical values will change a little bit because what we have here is that what we do. I mean, you can see this here. These are not observed processes; these are estimates. Okay, so these residuals are estimates. Okay, so this is not a time series that you observe directly. This is a time series that you estimate. You understand this? Okay, so you don't have any observation of the error of the equilibrium error. Okay, so there are no observations. There are just estimations, and this implies that since there are no estimations. No observations, no direct observations. You have to estimate them. The critical values of the Dickey-Fuller distribution have to be adjusted. Okay? So this is the implication. So these are estimates. Okay? Not observed or directly observed time series. Okay? So there are no direct observations for the time series. These are just the estimates. Okay, so and that means that this implies that the critical values of the Dickey-Fuller distribution have to be adjusted. Now, how this adjustment works, we're not going to look at that anymore. Okay, so there is a little adjustment here, and due to matter of time, we cannot consider that. But so the critical values of the Dickey-Fuller distribution will change because basically the error equilibrium is not directly observable. Okay? So what you have is just basically an estimation for that. No direct observation of the process. So we have different critical values. So if you perform this, you perform that test, okay, so this is usually augmented Dickey-Fuller test, you have to adjust the critical values. And of course the critical values for that, okay, so you can use this for your seminar, but this will not be relevant for the examination, okay. So the first one, okay, so you find basically two tables here, okay, and the appendix, okay. So the first one is being the critical values of Dickey-Fuller distribution. This is the regular one, okay, so for each of the models. And the second one refers to the adjusted ones, okay, where you test for cointegration, okay. And as you can see, they're a little bit different, okay. okay? But you don't have to do that for the exam, okay? So just if you want to use this for the seminar, you can basically look it up and see how it works. We don't do this anymore because you just got 5 minutes left, so of course this will not be relevant for the exam. Okay, so you don't have to test for cointegration here. Okay, but you should be able to know, or at least describe the procedure, how this works. Okay, so that's the only thing. But you don't have to know in detail how, basically, how these adjustments here of the distribution relate to. Okay. All right. Okay, so guys, if you have any questions of any kind, I think I have, two people have contacted me, so just for having a little chat afterwards, so after lecture. So, and since tomorrow we don't have any lectures, that will be the last one. But if you want to talk to me in person, you can. Okay, so just let me know. All right. And as I said before, for the examination, I just announced it. You can bring basically the printed version of the lecture notes. Okay, I have uploaded and updated the printed version of the lecture notes, so you can use that. And I have also included 4 blank pages that you can use for your own handwritten notes of any kind. Okay, so you can include this, and you can bring that, or you should bring that into the examination. All right? Okay? Yes?
Can we put post-its in the script?
You can. You can. But I think that it's just 70 pages or something. So, I mean, if you want, you can. Sure. Okay? And you can, you can add some notes, I don't care, right? So, but as long as it's not like, copying and pasting like, exercises or whatsoever, or papers or stuff like that. So, okay, I don't mind if you add some little notes or maybe lecture notes or whatsoever. But you're not supposed to print or write anything on the back side of the sheets on which that you use for printing. So maybe it would be a good idea if you just print it on let's say on both sides, okay, of the paper. But you don't have to. But if you don't print both sides, then you're not supposed to use the back sides of the sheets, because it would not be fair, I think. Okay. Now, guys, again, so a lot of people still ask me this. You don't have to prove anything in the examination. So I'm not going to ask you, okay, derive this formula, derive that formula, stuff like that. No, none of that stuff. I only did this just for you to understand where the formula is coming from. I mean, even that was not always complete, but you have to have a little intuition, okay, how these things relate to each other and where do the formulas coming from. I mean, if you don't understand where they're coming from, then basically it doesn't make much sense. So that's why I did this in the lecture, but you don't have to do this in the exam, okay? So there will be no surprise regarding this. What we have to do is, for instance, you have to examine whether or not, let's say, an autoregressive model is stationary or not, okay? And how this works, we did that already. Okay, so I'm going to give you certain parameters, specifications, whatsoever, and you have to examine whether or not the corresponding process is stationary. That's it. Okay? Either use a stationary triangle, okay, or you do the quadratic formula whatsoever. I mean, you remember this. Okay, hopefully. Anyway, so it's also in the lecture notes, so basically it's nothing new. So that could be one kind or one type of an example. Or let's say compute the long-run variance of a gauge process that I gave you in a specification. All right. So all you need to do is you have to plug in the parameters into the corresponding formulas. Okay. That's it. Okay. So I mean, guys, if I say show that the process is stationary, okay, this is not about proving something. Okay. All right. So please do not mix that up. I mean, just for you to understand, okay? So don't complain afterwards if I say, okay, show that the process is stationary whatsoever, because there are certain mechanisms that you have to apply. You only have to put these parameters into certain equations and examine whether or not the stationary property holds. Okay, so that's it. Okay, so please do not complain about this. Or either, let's say I'm going to give you like something like show that the Random variance is equal to, provided that the process is specified. So you don't have to prove that. Okay, I'm going to give you certain numbers. Okay, and then you just have to plug in. This is going to be one type. And the other one is going to be, or relate to certain tests that I use in most cases from your papers that I'm going to get. Okay? So for instance, whether or not there is an arch or gauge effect. Okay? Whether or not, for instance, I'm taking whatever, what kind of model. I mean, and I could use any type of model, it doesn't matter. Okay, so you have to calculate certain test statistics, okay, from the outputs that are given sometimes, okay, so for instance the coefficient of termination of a certain regression, blah blah blah, that is in a certain equation, whatever, and a Box-Pierce test or something like that, so you have to calculate the test statistics maybe, and you have to provide a critical value, and you're supposed to tell me whether or not you reject the null hypothesis or not. This is also part of the lecture notes. Okay, so there you also find some examples related to that, where you have an output. Okay, so you have a table, and you have to explain. Okay, same goes for stationarity test. So it can be something from maybe if you have a paper, maybe I take one or two of your tables that are from your table, from your paper, sorry. Okay? So maybe you recognize your own table in the exam. Could happen. Alright? So I'm using a screenshot or whatever. Or I'm taking something from the exercises, like the modified versions of them. Okay? And this will be the exam. So I'm using like, I don't know, I think, let me just say, 4 or 5 examples, okay, maybe, shorter ones, okay, so you have 60 minutes, 10 to 12 minutes for each, something like that, okay, I don't know, so that will be it, okay, and it will be, again, it will be more on the practical side, okay, so both from the, just from the theoretical perspective that you examine, okay, you put certain parameters into the right place. That's it. But not proven or deriving formulas whatsoever. Okay? So that's not going to be the case. Anyways. Alright. Okay. Yeah, I think it will not be difficult, so don't be afraid. Alright? Try to focus on the paper, of course. The examination is in 3 weeks, I think. Right? So I'm going to consider all topics except for, cointegration. I'm not going to do the test for cointegration. Okay, but it could be something like, yeah, explain what error correction means and stuff like that. So maybe you can do that just briefly or something like that. Or what are the ideas of the Dickey-Fuller test for cointegration? So how does it work? Then you explain, okay, first regression, this and that, second regression, whatever. Okay? That's it. But nothing in terms of, detailed, formal explanations. None of that stuff. Okay? Yes?
When is our exam again? In February?
Yeah. I can't remember. Is that 8th? Yeah. Something like that. So, Friday, is it Friday or Thursday? Friday, right? Okay. Good. Now, that's it. So, and of course, the deadline for paper and video submission is in the week before. So, please do not forget that. Okay? You're supposed to watch your presentations because as I said before, I'm using your results for the exam. So it can happen that I'm having your table, okay? So try to make it easier for your fellow students, okay? So not too complicated. Leave out redundancies and stuff like that, okay? You don't need to include information that I don't need to know, okay? So for instance, there are people who give me the information from which folder they upload the data for the program. Who cares? Okay, so I don't care. I mean, these are things that you're not supposed to use for neither for the paper nor for the presentation, because they are redundant information, and this is a redundant information. And if you use that, I'm going to penalize you. Okay, so do not provide me information which you don't use. Period. Okay, so no redundancies, none. Okay, some people like, you know, put in like whatever pictures and tables and stuff, you know, and they don't talk about them just for like decoration and whatever. I mean, this is not, you know, guys, this is not a beauty contest. This is more like, you know, it's a scientific paper, so please talk about the things that you are providing me. Okay, so if you don't talk about it, then don't provide it. Period. Okay. So that's basically the approach that I would give you. And again, if you have like, you know, questions or comments or whatever, okay, then don't forget to, or do not hesitate to contact me. Okay.